In this project, we will learn how to incorporate a thumb joystick in your electronic circuits. We will be building a game with the joystick and an 8x8 matrix LED. The object of the game is to capture the falling balls. If you can do that within a specified time, you win the game. You will also be introduced to the MAX7219.matrix module, and we will leverage a couple third-party libraries to help us control our 8x8 LED matrix. This project is going to be a lot of fun. Let's take a look at the objectives. By successfully completing this project, you will have mastered the following items. You will understand how to connect and take positional readings from a thumb joystick in a circuit. You will also understand how a MAX7219 dot matrix module can be used to help control an 8x8 LED matrix. And we will also see how some third-party libraries can be used to help make controlling our LED matrix much simpler. If you are ready to begin, let's get this project started. Here are the parts we will need: an Arduino Uno, a USB cable, a breadboard, a thumb joystick, an 8x8 LED matrix display, a MAX7219 dot matrix module, and connecting wires. Let's first address the operation of a thumb joystick. This is a very handy component for your electronics projects. It can allow you to control servos, motors, or basically any component where you'd want to control movement and motion. The joystick typically has 5 pins. The ground pin will be connected to ground. The plus 5 volts, like its name implies, will be connected to the 5-volt pin on the Arduino. The VRX and VRY pins, or horizontal and vertical pins, are used to measure the horizontal and vertical distance moved by the joystick. Analog readings of voltages taken at these pins have a value in the range of 0 to 1024. For example, if the joystick is all the way to the left, the horizontal pin, or VRX, might have a reading of 0. When it is in the middle position, the reading might be 512, and when it is all the way to the right, a reading taken might be 1024. Thus, you can pinpoint the horizontal position of the joystick by determining the value in this 0 to 1024 range, and you can map that accordingly to the position of your servo or whatever directional component you want to control. A similar principle also applies to the VRY, or vertical pin. In order to determine if the joystick button is pressed, the select pin can be used. If a reading taken at this pin was high, the joystick was pressed. If it was low, the joystick was not pressed. Now we will look at the MAX7219 module in more detail. This is a handy hardware component that interfaces to your 8x8 LED matrix. The hardware, coupled with a third-party library for the MAX7219, makes it easy to accurately light and display any individual LED or patterns of LEDs on the matrix. The MAX7219 also makes it possible to daisy chain several LED matrices together to make a complex display. In order to communicate with the LED matrix, the SPI, or Serial Peripheral Interface Protocol, is used. This is a synchronous serial data protocol used by microcontrollers for communicating with one or more peripheral devices quickly over short distances. It can also be used for communication between two microcontrollers. We will need to connect 5 pins to the Arduino. VCC is connected to 5 volts, and ground is connected to ground. DIN is connected to pin 11 on the Arduino, which is the master out slave in used in SPI communications, and the CS pin is connected to the slave select pin 10. Finally, the clock pin is connected to the serial clock, which is pin 13 on Arduino. We will use two third-party libraries to help us communicate with the LED matrix via the MAX7219 module. These are the MAX72XX panel library and the Adafruit graphics library. We will see these in more detail when we look at the code. Let's take a look at the circuit diagram for basic joystick operation. In this circuit, we'll just be looking at how the joystick interfaces with Arduino and how we can take measurements to determine the position of the joystick. As you remember, the joystick has 5 pins, and VCC is going to be connected to 5 volts on the Arduino. Then we have the VRY connection that goes to analog pin A0 on the Arduino. That measures the vertical direction of the joystick. The next connection is VRX that goes to pin A1 on the Arduino, and that measures the horizontal distance of the joystick. The other pin determines if the joystick is pressed or not, the select pin that is connected to A2 on the Arduino. And finally, the ground pin is grounded on the Arduino. That's the wiring for our joystick circuit. Okay, let's go ahead and wire up our first circuit where we will see how we connect the joystick to the Arduino. This is the thumb joystick. As you'll notice, there are 5 pins. We have the first one being ground, then you have the 5 volts. VRX measures the horizontal position, then you have VRY, and finally the SW pin or the select pin will tell us if the thumb joystick was pressed or not. To make things a little simpler in order to perform the connection with the joystick, I have some female to male connecting wires. These actually come in pretty handy because they can just connect directly to the header pins on our joystick. So I'll go ahead and connect those. Those are 3 and the bottom 2. Alright, so now that's a nice solid connection, and the end of those pins are male header pins. So this makes it convenient. Okay, so the first pin, ground, which is the green pin, goes to ground. I'll just connect that to the ground rail on the breadboard. The second pin is the 5 volt pin, which is a yellow pin. I'll connect that to the positive rail. The VRX goes to A1, that's our orange wire here. Goes to A1 on the Arduino. So I'll make that connection. The VRY goes to A0, that's the red wire. And the select pin, which is the last one, brown wire, goes to A2. So I'll make that connection here. Okay, so with that being connected, I'll just go ahead and connect the 5 volts to the 5 volts rail on the breadboard from the Arduino. And then I'll do the ground to the ground rail. Okay, so that completes the wiring for our joystick. Okay, let's go ahead and upload the code. And I'll open the serial monitor. So as you can see, the joystick is currently in the middle, and you'll notice the vertical measurement is 525 and the horizontal is 511. That's about the middle of 1024. So now I'll go ahead and let's move the joystick all the way to the left. in a horizontal motion. So if I take it all the way to the left, you'll see that the horizontal reading changed to 1. All right, so that's all the way to the left. Now I'll move the joystick all the way to the right, and you see the horizontal reading changed to 1021. Okay, so by moving the joystick left and right, I'm able to get values within that range of 1 to 1021, and I'll be able to tell the position of my joystick in that horizontal axis. Let's take a look at the vertical axis now. As you'll see, right now it's currently at about 525, and that's in the middle or rest position. I'm going to push the joystick to the top, all the way to the top. You'll notice the vertical reading goes to 1, 0, and 1, about approximately. And I'm going to push the joystick now all the way down to the bottom, and you'll see that vertical reading goes to 1020 or so. For the actual pressing of the joystick, so now you can see that select is not pressed. I'm going to press in, and there you see the pressed showing up, and I'm going to release it. You're going to see not pressed again, and I'm going to press it again, and you see the pressed showing up. So we're able to take readings from virtually any position on the joystick, and we can use that to determine where the joystick is, and we can control the movement of another device connected to the Arduino based on the position of our joystick. Okay, let's take a look at the code for our joystick operation. At the beginning, we simply define and declare a couple of global variables. So for the vertical, it's declared as a constant, and that's connected to pin A0 on the Arduino. The horizontal pin on the joystick is connected to pin A1 on the Arduino, and the select pin is connected to pin A2 on the Arduino. Next, in our setup function, what we are essentially doing here is enabling the pull-up resistor on that select pin. This was an older way of doing it, so we can do pin mode select specified as an input, and then do a digital write to the select pin specifying a high value. That would turn on that pull-up resistor. Or alternatively, we could do the pin mode select, and then we pass in input pull-up as the argument. That would accomplish the same thing. Next, we set up the speed for the serial communication. So this is syntax you've seen before. In the loop function, we have a couple of variables that we want to capture and store the position of the joystick. So we have vertical, horizontal, and select. Next, we take readings for those variables. So for vertical, we do an analog read on that vertical pin. For the horizontal, similarly an analog read on the horizontal pin. And on select, we do a digital read on the select pin because we just want to determine if it's a high or a low. It will be high if it's not pressed, and low if the button is pressed. Next, we simply print out the values of those readings to the serial monitor, and that's how we're able to see those values for vertical, horizontal, and for the status of the select pin if it's pressed or not. That's our code. Very simple and very straightforward.